Yan, okay. So, start tayo ng static force method. So, dito sa aking lecture, chapter 3. Although, baka mabago to, no? Depende kasi from time to time, nire-revise ko itong PDF. Okay. So, the importance of earthquake loading. Seismic load will most likely govern in a 4-story RC building. Yes, from the concept na uh, ano nga yung sinusunod natin sa earthquake na formula from Newton's second law of motion, which is force equals mass times acceleration. Basically yan, no? Newton's law of motion. Law of motion. What does it say? So as your mass increases, definitely your force increases. Okay? And with that, dependent din yung acceleration mo. Okay? Now, so, habang bumibigat yung building, tumataas yung force. Therefore, mas malaki ang chance na mag-govern ang seismic load than the wind load. Okay. Sa mga lecture ko before, take note, ang wind loading, ang formula niyan, if I remember correctly, ano to QZ equals 47.3 times 10 to the negative 6 yata. KZ, KZT, KD, V squared, I, W, I. Okay. Yan. And it turns out, on the average, ang value nito is just about 2 to 3 kilopascal. Yan lang, no? 2 to 3 kilopascal. And also, so for example, ito yung structure mo. That is almost constant all throughout. Not really constant, pero you can just assume na sa yung building mo, say typical low-rise, no? 4-story. 1, 2, 2, 3, 4. Yan, ang ganyan, no? 4-story. Yan. Yung buong building na yan hanggang dyan, sabihin na natin 3 kPa. Then multiply mo lang sa tributary. No? Sa tributary ng column. So basically, yun lang yung pressure. Whereas sa earthquake, habang bumibigat yung structure mo, bibigat din yung, tataas din yung force mo. Okay? Now, pagdating sa code, no, which we are following sa structural, we're using right now NSCP 2015. Okay? Which is, again, this is patterned after, say, American code. Okay? So, ano yung American code na counterpart niyan? UBC 1997. Ano pa ba? ASCE 705. Okay? You have to remember na we are an American colony. So, therefore, we adopted yung code nila. Okay. Now, ano yung corresponding equation ng ating static force method sa NSCP? I just remembered kasi I'm always using 2010. It's in chapter 2. Chapter 2. I think I have this here. Where is that? NSCP. Take note, meron akong hard copy. No? So, it's okay na meron akong soft copy. That is chapter 2. Yan. Minimum design loads. Here you will see kung ano ang mga provision regarding sa earthquake. If you will look at earthquake loading, yan. Ano ko na to? Na-bookmark ko na to. So, ito basically yung 4 na formulas. Yan. So, ito yung lagi kong talagang kabisado ko, no? V equals CVI over RT W. So, ito yung most common. Okay. If you will notice, itong formula na to, this is analogous to this formula above ni Newton. How? W is actually your what? Lang ha? Pagpuin ko siya. Oops, hindi ko siya mabago. Close pen. Okay. Lang. W is actually your mass. Yan. Ulitin ko na nga lang. Force equals mass times acceleration. W is actually your mass. Therefore, and then V is actually your force. And this whole coefficient here is your acceleration. Yan yung acceleration. See? So, ito yung itsura niya sa code natin. In short, to get the V, which is the base shear, this is the base shear, yan, you need first to get the weight or the mass of the building. Weight of building. And then find these coefficients from the NSCP, okay, which is CV, I, R, and T. Okay, I is actually the importance factor. R is the seismic modification factor. O yung iba, ang tawag dito is the ductility factor, the response modification factor. Okay, ductility factor. T is the period of the building. CV is coefficients. Okay. Okay. CV is the coefficient. Okay. So basically, yan yung ating equation for the static force method. Explain ko to later, how we get this. No? Now, once you have that, the base shear, and then base shear is roughly, I would say, about 10% to 20% of weight of building. 10% to 20% of the weight of the building. If your R is 8.5. R is 8.5. Which is basically, I would say, in general, parang default. No? Default sa Philippines because we're in a seismic region. Papakita ko why. Next is okay, once you get your V, oops, page, okay, so meron ka ng V, ito yun, i-distribute ngayon natin yan. So ito yung ating building, so we will distribute that vertically. Okay, kaya nga static force, no? yung base shear na nakuha mo na mag-act sa building mo, syempre madidistribute vertically dun sa structure. And then may formula yon. No? What's the formula of that? It's here. Where's that? Yeah, no? Seismic mass computation. Yeah. So, kinuha ko na yung snapshot niya. Yan. No? So, ito yung ating lateral force distribution. Where's the formula? Ito tama yung formula. Yung mas ano pa dito. As per NSCP, gusto ko yung general formula. Eto. Yan. Okay, that's it. So, ito yung general formula niya. Ayaw, lumabas. Okay, copy ko to. And paste here. Yan. So, ito yung ating general formula. Okay, yan. Once you have the V, get the F sub T, may formula din to. Actually, ano lang yan, no? Yan yung extra force dun sa rooftop. Then, to apply mo to, WX, HX. WX is simply the weight per story. HX is the corresponding height from the story, from the ground. So, yan. H1, H2, H3, and H4. May example naman sa Ibo. So that's it. No, that will be the formula. And of course, divide mo yan sa summation of Wi, Hi. No, then you will now find Fx, no, which is per floor. No, per floor. So say F1, F2, F3, F4. Okay. So, na-distribute mo na, no? Vertically. That means, ito yung equivalent force, equivalent static force at second floor, at third floor, fourth floor, and the roof level. Siyempre, plan-wise, ito yung itsura ng building natin. For example, yan, no? Say, meron ka dito. Okay. Meron ko itong dalawa para consistent. So, say, plan-wise, say this is, I may say, second floor framing. Yeah, second floor framing plan. Yeah. Itong F1 na to, which is acting sa second floor, is say ito. Diba? F1. You will notice, itong F1 na to, mag-act dito sa second floor. Siyempre, madi-redistribute yan, no? Per frame. Okay. Yan. Okay. So therefore, itong F1 na nakuha natin from this formula here will further be redistributed, will be further distributed sa frames, no, ng ating building. Depende sa framing ng building mo. No? So ganun din dito sa third floor, fourth floor, and roof. No, you will do the same on each level. And then, paano mo naman i-distribute yung F1 dito, no? Dito sa ating building? Well, it depends dun sa stiffness ng iyong building or ng iyong frame dito. No? Say ito ay grade A, grade B, grade C, grade D. So, syempre, gawin ko na lang bilog, ha? So, yan yung mga columns. Yan. Yan. So, yan. So, magdedepende yung distribution ng forces na yan sa framing plan mo. No? Okay. So for example, no, ano na lang, no, very rough estimate. For example, ang na-compute nating F1 is 400 kilonewton. Now, assuming na lahat to ay equal, no? Lahat yan, lahat ng frame na yan, equal yung column, okay? Suggesting na na equal yung frame, stiffness ng frame, uh, roughly, you can just assume approximately na itong dito will be just around 100. 100, 100, 100. Okay. Then, yun nga, no? You will do that process all the way to the roof. Then, uh, extract ko ngayon tong, if you do that same process all the way to the roof, ngayon extract ko tong frame D. Extract ko yung frame D. So, yung frame D. And, 2, 3. Ayan, no? So, sabi ko nga, rough calculation, this is just 100. Tapos, say, ang nakuha ko dito from the F to here, assume na lang ako na 200. Ito ay another 200. And then another, say, 250. So, yan na yung final sets of forces mo sa frame D. Sulat ko dito, frame D. So, you're now going to analyze this lateral force, no, method. So, what's the lateral force method na natutunan nyo? Either factor, portal, or cantilever. So, that's it. So that means once you went on this stage, that means balik ka na sa structural analysis, indeterminate structural analysis. Okay, let's say portal method. Therefore, after that, using portal method, you can now generate the corresponding shear and moment diagram ng frame na to. Sulat ko na lang yung, for example, typical moment diagram. Typical moment diagram nito will be something like ganito. Yan. Ganyan. Yan. Medyo crowded, no? Okay. Yan. Yan. Okay. So, ganyan. Moment diagram ng column. And then, for the beams, okay. So, yan. So, ito yung, say, moment diagram sa column. Ito naman yung moment diagram sa beam. Wait lang. Mali. Ganito dapat yan. Yan. Ganyan. Okay. Medyo i-zoom in ko to, no? Okay. Yan, no? Kita nyo? So, if I will redraw that, ganito yan. I-zoom in ko yan, yung portion na yan. Okay. 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 So, kung ito yung aking okay, yan yung joint ng column and beam. Okay, ito. So, kung ito yung aking moment diagram ng column, dapat ang moment diagram ko ng beam, something like this. Diba? Yan. Para consistent. Okay? So, negative moment dito, and then negative moment dito sa portion B. Okay? I see. Okay, that's it. So, meron tayong example sa ating ebook, which is this. Yeah. So, first discussion, the seismic mass. Okay. Okay. So, ito yung ating window split. Para makikita nyo yung, for example, yan yung ating, okay, yan yung ating typical frame. So, we have 2, 3, 4, 5. Okay. Kaya ang ating sa ebook, meron kang how many level? Second floor, third, fourth, what's this? I think the roof. Okay. So anyway, so you need to get the mass of the building. So ano yung mga nagko-contribute ng mass? Yung dead load, dead load or the self weight of the structure, unang-una. Of course, the weight of the column, weight ng beam, weight ng slab, ng stairs, yung exterior wall na nakapaligid, interior wall, yung floor finish, yung ceiling, of course, yung ducting, electromech, okay, ano pa, yung mga laman, yung structure mo. So, typical, dito, calculation. So, 24 kilonewton per cubic meter. Yan yung unit weight, the concrete, times 0.5. Say, ito yung cross section mo, times yung 36 pieces na column, then yung length. So, in short, and then multiply that, get the product, you will get a weight of 820.8 kilonewton. Okay. So, ganoon din sa beam. Kunin mo lang yung mga self-weight ng structure mo. For the beam, meron kang 6 pieces on each side, Ito, okay. For the slab, 2.4 kilopascal. Multiply mo doon sa panel, tapos kung ilang peraso. So, yan. Why 2.4 kilopascal? Ano to, So, I think ang thickness ng stud nito is 0.1 meter or 100 mm. So, 0.1 times 24 kilonewton per cubic is 2.4 kilopascal. Okay, then the stairs, ito. Okay. Floor finish, typical yung ating load ng floor finish is 0.77 kilopascal. Okay, the ceiling, kung ano man yung nasa design criteria mo. Yan, 0.48 kilopascal, multiply mo sa area. So, yung electromech mo, kung ano yung weight ng electromech mo, multiply mo sa area. So, that's it. Then, you will get the weight per level. Okay? So, level 1, level 2 pala to. Okay. Level 3, then level 4 is the roof deck. Okay? So, in short, sa level 1 or the second floor, what's this? 3,025.457 yung weight dito. Okay, so level 2, 3,040, so on so forth. So, after that, where's the application of this here? So, pag nakuha mo na yung weight, apply mo na yung formula natin. Yung CVIW over RT. And then yung minimum base shear na formula, 0.11 CAIW. Vmax, 2.5 CAIW over R. Okay. Ito naman, yung formula po for zone 4. Okay. Okay. And which is, nandito yan. Sa kabilang page. Yan. So, inulit ko lang yung mga weight dito. Nilagay lang dito. Okay, total mo yan. So, that is your total weight ng structure mo, no? 18,853.719 something. Okay. Okay. So, that's it. Substitute mo na itong W dito sa mga formulas natin. Ito yung CVIW over RT. Yan. Substitute mo dyan. Okay. Medyo bibilisan ko lang to kasi nga babalikan ko naman na yung discussion ng mga how to get the coefficients. So, yun. Once you apply that dun sa mga formula na yan, of course, you will choose which among those formula sino yung nag-govern na base year. Yan. Ito na yun. No? Ito yung nag-govern. Then, apply this formula, this tabulation to get the distribution ng forces vertically. For example, ito yung weight natin, no, per floor. Ito yung height distances from the ground. For example, yung level 4, ang distance niya from the ground is 14.8. Si level 3, 11.2. Si level 2, 3.6. And then si level 1, what's this? This is 7.6 and then this is 4. No? Okay, Wx times Hx. Ito yun. Okay, then get the summation of that. Ito yun. Then apply this formula. This over this. Okay, this over this. Ito. This over this. Ito. Okay, so on so forth. And then V equals yung formula natin kanina from NSCP, which is ito. Yan, no? Okay, Wx, Hx. Yan. Okay, so ito na yun, no? That's the same. So, Wx, Hx over summation Wx, Hx. Okay. So, V. Okay. So, multiply mo to dun sa ating base shear, no? Which is this. No? This times this is this, Fx. Yan. Kaya makikita nyo sa baba, 288, ito. 552, ito. 809, ito. 789, ito. O yan, no? So, ito yung mga forces na i-distribute mo vertically. Yan. Okay? So, yun muna tayo, no? Dito muna tayo.